Hi class, right now we're going to learn about lesson 6.3, making comparative inferences about populations. So yesterday how we were making inferences about a singular population, now we're going to be making inferences about two or more populations and comparing them to one another. So let's start off with a definition. So a convenient sample is a sample that is convenient to take. For example, if I choose to survey the 5 people closest to me because it would be easy, this would be a convenient sample. So a convenient sample wouldn't really be seen as a representative sample because it doesn't include the entire population, right? If you're only talking to the 5 people closest to you, then that wouldn't be representative of the entire population. It'd only be representative of the people around you. So let's get into our key concept here. So you can use data displays to make informal comparative inferences about 2 or more populations. We can do this by looking at the shapes of the data and the displays and the measures of the data. So if we look at dataset A and dataset B to our left and right, to our right here, we see that the median of both datas is at 5. So right off the bat, we know that these two datasets share a median point at 5. We can also see that in dataset B, our box here and our range is much higher, right? It goes from 1 to 10 as opposed to 2 to 9. And our box on our box and whiskers goes from 4 to 9 as opposed to 4 to 7, which means that dataset B has a greater variation, or there's a lot more data points in there that are spread out throughout the entire population, as opposed to dataset A where it's all clumped in towards the middle. So those are 2 inferences we can make about those datasets there. So let's look at this question here. The box plot describes the heights of flowers selected randomly from 2 gardens. Use the box plots to answer questions 4 and 5. So you want to find the median of each sample. So where would the median be in garden sample Y? Well, it's right here where this line is. That's going to be our median, and that is at 6. So our median in garden Y is 6 inches, or 6 inches height of flowers. Now let's look in garden Z. In garden Z here, our median is going to be about 4 inches. So in garden A, it's at 6 inches, and garden 4 is at 4 inches. Now, the only way I found those was just looking at the points where those lines come in the box and whiskers diagram. All right, so now we need to make comparative inferences about the flowers in the 2 gardens. So I want you guys to pause the video for a minute and then try that yourself. All right, so let's make some inferences about these gardens. Well, right off the bat, we can see that garden Z has a greater variation in its flowers, right? There's a large number of flowers here in their upper and lower quartiles, so we know that they have a greater variation. So garden Z, greater variation. Well, just how garden Z has greater variation, we can see that garden Y has a greater range, right? Now the range has to do with the highest point minus the lowest point, and that will give you the range for all of your set here. So for our range on garden Y, it's going to be 9 minus 1, which is 8. And our range on garden Z is 8 minus 1, which is 7. So garden Y has a greater range. All right, let's go into our last problem here. So higher order thinking. The box plot shows the daily average high temperatures of 2 cities from January to December. Which city should you live in if you want a greater variability in temperature? And it wants us to explain. All right, give you guys about 1 minute to pause this, think about this for yourself, and then I'll go over it. So if we're talking about our variation here, we want to talk about which one has a greater variation in its upper and lower quartiles in this box and whisker diagram, or we want to see which box is bigger here. So in city X, the variation goes from 30 to 50, and in city Y, it goes from 25 to 50. So city Y has a larger variation, or a greater variation, because it has its upper and lower quartiles, or this point right here, this edge of this box, and this edge of this box are further apart. So if we want to live in a city with greater variability in temperature, we'd want to live in city Y. All right, that was it for that slideshow, guys. I hope you learned a little bit about comparative inferences between populations. So let's remember what we were doing in this chapter was talking about two populations and comparing them based off the data points we have.